Question number 64. A 20 microfarad capacitor is joined to a battery of EMF 6 volt through a resistance of 100 ohm. Find the charge on the capacitor 2 milliseconds after connections are made. So basically we charge the capacitor to a certain volt, and then we are charging it through a resistance. So if you have not seen, you may want to check my video on discharging the capacitor and derivation of the formula. I'm going to directly write this for when this battery is charged and you short it, kind of connect this resistor through a resistor to this charge, a current starts flowing through this resistor, and initially this current, and as a result the charge on this capacitor, it starts going down. And the way it goes down is using an exponential curve, where this t is the time, this q, which is a function of t, is reducing with time. And this is the formula for this current charge on this capacitor. Q is equal to q naught e to the power minus t by RC. You can verify this formula. At t is equal to 0, this becomes e to the power 0, and q becomes q0, which is the initial value, the initial charge of the capacitor. When t becomes infinite, this becomes 1 upon e to the power infinite, or 1 upon infinite, or 0. So at infinite, t tends to infinite, q becomes q0, and our formula is correct. So q naught is the initial charge on this capacitor at t is equal to 0, and that they have given 60 microcoulomb. Let me verify this here. Battery is charged to a battery of EMF. Okay, so they have not given this charge 60 microcoulomb. It comes by the fact that the CV and C they have given its battery EMF of 6 volt. So 6 into 20, that becomes, okay, so C, Q is equal to CV. So we will write, we remove this because it does not look good, 20 microfarad multiplied by 6 volt, 6, that becomes 120. So the initial charge on it is 120 microfarad. So we will make it 120. All these things becomes 120. So Q is equal to 120 multiplied by e to the power of